We are now at question 5. A function is defined as f of x equal, and we have a piecewise function here, for x plus 4 cubed. It holds when x is less than or equal to 2. Well, less than negative 2, sorry. And the function is negative 10 when x equal negative 2. And the function is x squared plus 8x minus 1 when x is greater than minus 2. So part 1, determine the value of f of minus 2. So look at the range where x is negative 2. And when x is negative 2, the function is negative 10. Determine the limit as x approaches negative 2. Now to do this, we need to find what we call the left-hand limit and the right-hand limit. So let's deal with both of them. So left-hand limit. And the left-hand limit is simply for when x is less than the value here, in this case negative 2. So limit x approaches minus 2 from the left. And we look at the domain, it's actually when x is less than negative 2, the function is x plus 4 all cubed. So we're going to replace x with negative 2. So this becomes negative 2 plus 4 all cubed. That's actually 2 cubed, which is 8. Let's find the right-hand limit now. So the right-hand limit is for when x is greater than the value here, which is negative 2. So the right-hand limit, as x approaches minus 2 from the right to the function. Well, let me just write that better. So I need to put this below. So is a limit. So it's a limit x approaches minus 2 from the right. So if we look at the function from the right, meaning x is greater than minus 2. So when x is greater than minus 2, that's the right-hand limit, replacing x with minus 2. So this becomes minus 2 all square plus 8 times minus 2 plus 1. So that's minus 2 all square plus 8 times minus 2 plus 1. So minus 2 all square is 4. 8 times minus 2, that's minus 16 plus 1. So 4 take away 16, that's negative 12. Negative 12 plus 1, that's negative 11. So notice the left-hand limit is 8. And left-hand limit again for when x is less than 2. And the right-hand limit for when x greater than 2 is a different value, which is negative 11. So the limits are not the same. So left-hand limit is not equal to the right-hand limit. One is 8, one is negative 11. So the conclusion is that limit does not exist. So therefore, the limit does not exist. For the limit to exist, then the left-hand limit and the right-hand limit has to be the same at the point, in this case, negative 2. Hence or otherwise, determine whether f is continuous at x equal negative 2. So the conclusion, f is not continuous. Since not continuous at negative 2, that is at negative 2, at x equal negative 2, since the limit does not exist as x approaches negative 2. So it's not continuous at x equal negative 2, since the limit does not exist as x approaches negative 2. Part B, evaluate the limit of sine theta over sine 4 theta as theta approaches 0 Alright, so the first thing we'll do is we'll try what we call direct substitution. So we're going to substitute 0 for theta in the function there. So we have sine 0, this will be sine 0 over sine 4 times 0, which is 0. So sine 0 over sine 0, sine 0 is 0, so 0 is 0, and we say this is indeterminate. Indeterminate. So we have to try something else, so we don't accept 0 over 0 as our solution. Alright, so we can do several things here, but let's see if we can rewrite. Let's see if we can rewrite the function and do any factoring. So we're going to rewrite the problem. So, alright, we're going to rewrite the problem as limit as theta approaches 0. In the bracket there is a sine theta over, no, sine 4 theta. Recall that. Let's recall that. Recall that sine 2 theta, double angle, is 2 sine theta cos theta, which means that sine 4 theta, look at sine 4 theta as sine 2 times 2 theta. So sine 4 theta is actually 2 sine 2 theta cos 2 theta. Applying the double angle formula there. Alright, as this we call sine 2 theta is 2 sine, and you take half the angle. So you split 2 theta as theta theta. Right, guys? You split 4 theta as 2 theta 2 theta. Right? Now we also, let's continue. So this is limit. Theta approaches 0. Numerator is still sine theta. Now sine 2 theta again. We can rewrite sine 2 theta as 2 sine theta cos theta. So sine 2 theta is the same thing as, just bracket it, just to separate it, 2 sine theta cos theta. And outside here we have cos 2 theta. And what you can see now, we can factor out, we can do some cancellation here. So sine theta and itself here is 1, sine theta down here cancel. So we're left with 1 over 2 times 2, 4. So 4 cos theta times cos 2 theta. So we're not troubling the cos, because cos 0 is 1. But sine 0 is 0. So, alright, so the cos, that's okay. So now we can substitute theta is 0. So we have 1 over 4 cos 0 times cos 2 times 0, which is 0. Alright, so the value of cos 0 is 1. So what, that's with 1 over 4. So our solution is a quarter or 0.25. Let's move on. Part C. Part C, a function g is defined as g of x equal to x cubed minus 3x squared. Determine the stationary points of g and the nature of the stationary points. So we're going to let's call the function y, x cubed minus 3x squared. Now to get the stationary points, we're going to equate dy by dx to 0. So we're going to equate dy by dx to 0. That's how we find stationary points. So dy by dx, that's 3x squared, multiply by the power, subtract 1 from the power, 2 times that, that's negative 6, x to the power of 1, and of course we equate to 0. So we equate dy by dx to 0, and then we solve. So solve, now we can simply factor out 3x, factor out 3x, we're left with x minus 2 equals 0, and then to solve we equate both factors to 0. So equate 3x to 0 or x minus 2 to 0. Divide both sides by 3. X equals 0 or x equal to 2. And then to get the corresponding y value, remember y equals x cubed. Y is whatever the function is, x cubed minus 3x squared. So y equals x cubed minus 3x squared. So get the corresponding y value. We replace we place 0 in the function, so the y value will be 0 cube minus 3 times 0 square, which is 0. And when x equal to 2, the y value will be 2 cube, which is 8. 2 times 2 times 2, and then here is minus 3 times 2 square. Now 2 square is 4. Multiply that by 3, that's 12, right? That's negative 4. So therefore, the stationary points, stationary, or turning points, the stationary points are 0, 0, and when x is 2, y is negative 4. So 0, 0, and 2, negative 4 are our stationary points. We're also asked to determine nature, to determine whether the turning points are maximum or minimum. So to do that, we need a second derivative. Let's find our second derivative now. So du2y by dx squared. So we're classifying whether maximum or minimum. So remember that dy by dx was this, 3x squared minus 6x. So the second derivative, differentiate again, 2 times 3, so 6x minus 6. So the second derivative is 6x, so I've gone too far, so 6x minus 6. So let's test the points now. So let's substitute the different x values. When x is 0, at x equals 0, the second derivative is equal to 6 times 0, which is 0, minus 6, that's negative 6. And negative 6 is less than 0. So if the second derivative is less than 0, that's a maximum. Alright, so 0, 0, this point is a maximum point. So we expect the other to be a minimum, but anyway, let's do the test. So at the other x value, what was our other x value now? 2. At x equal to 2, the second derivative, d2y by dx squared, is equal to 6x minus 6. So x is 2. So 6 2 is 12. Minus 6, that's equal to 6, which is bigger than 0. And when the second derivative is bigger than 0, then that's a minimum. So when x is 2, so this point 2, negative 4 is a minimum point. This point is a minimum point. Let me put down here, minimum. So 0, 0 is a maximum. 2, negative 4 is a minimum. Next, hence or otherwise, sketch the graph showing its intercepts, stationary points, and any other important features. Right, let's do the sketch now. So you remember that the graph was y equal to x cubed minus 3x squared. This was a function. So outside of the minimum points, we also need to know where the graph cuts the x-axis and the y-axis. Alright? So we know at x equals 0, y equal to 0. So we know the graph passes through 0, 0. Alright? So when the graph passes through 0, 0. And by the way, 0, 0 was also the maximum, remember? And remember that this is 0, 0. Alright, so we want to know where the graph cuts the x-axis, right? So cuts a graph cuts x-axis when the y is 0. So replace the y with 0. We get 0 equal x cubed minus 3x squared, and we can factor out x squared. We'll be left with x minus 3. And we equate this to 0. So the graph cuts the x-axis, so equate the factors to 0. We have x squared equal to 0, which means that from that x will be equal to 0, right? So, and we already know the graph cuts the x-axis at 0. Also, x minus 3, the other factor, is equal to 0. Solve this, x equal to 3. So we know the graph cuts the x-axis at 0. It also cuts the x-axis at 3. Let me just label here. So it's 1, 2, 3. So the graph cuts the x-axis at 3. Remember the turning points were 0, 0, and 2, negative 4. Maximum at 0, 0, minimum at 2, negative 4. Let's plot the point 2, negative 4. So this is 1, negative 1, negative 2, negative 3, negative 4. So 2, negative 4 will be around here. Was it 2, negative 4? Yes, 2, negative 4. That's the minimum point, and the maximum is 0, 0. Cuts the x-axis at these spots. So the maximum is 0, 0. The minimum is 2, negative 4. So the graph will look something like that. Let's see if I draw a better graph. So it minimum and cut the x-axis at positive 3. Also minimum there. Cut the x-axis also at 0. But also turns. Alright, so the graph will look something like that. So this is a graph of y equal x cubed minus 3x squared. Let's move on to question 6. Question 6. Calculate the volume of the solid generated by revolving the region bounded by the graphs x equal to root y and y equal to 2x about the y-axis. Let me do a quick sketch of this of these two graphs. So we have x equal to root, and by the way, x equal to root y. If we square both sides, what we have is x squared, and just square root y, you get y, right? So that's one of the, it's a curve. And then the other graph is y equal to 2x, right? Let me do a quick sketch of both of these graphs. Right, so we have our x-axis, we have our y-axis. So y equal x squared, 0. Y equal x squared, of course, will look something like that. It's a graph y equal x squared. And y equal to 2x is a straight line. Will look something like that. It's the graph of y equal to 2x. So the bounded region mentioned here, I imagine, is this region. Volume of revolution is about the y-axis. So we need, it's about the y-axis. So we need the point of intersection. So we have one graph is y equal x squared, taken from x equal root y. The other is y equal to 2x. So we can solve simultaneously. Both of them equal to y. So we can equate x squared to 2x. We group everything on one side. Factor out the x. We have x minus 2. Therefore, x equal to 0. Or x minus 2 equals 0. So x equal to 2. And we can see there the graph cuts the x-axis at 0. And also the y-axis at 0. And you'll notice if x is 0, whichever one of these you substitute this in, the y is 0. And if x is 2, whichever one of these you use, you get y equal to 2 times 2, or 2 squared. So y is 4. So the point of intersection here is actually point 2, 4. So this point is 2, 4. So I do a thing here. 2 on the x, 4 on the y. What we are using is about the y-axis. So we'll be using the y limits, 0, 4. So the formula for volume about the y-axis, the formula for volume, is pi into the integral of x squared times dy. Alright, but it's actually two functions. So x squared. So I'm going to do x squared. X squared subscript 1 minus x squared subscript 2. Since it's two functions, all right, we're going to be taking the difference. So the volume is pi times the integral, and by the y limits, so I'm going to call the y1, y2 to represent the limits. y1 is the lower limit. In this case, y1 would be 0, y2 would be 4, the upper limit, and then the graph. So it's we have two graphs, all right. One for the x squared equal to y, that's the curve. So the x squared here, we'll call it x1. So this would be our x1, right? And this would be our x2 for the other function, which is the line. So x1 squared, that's y. Minus, and the other function, x2 squared. Now from here, x2, if we divide both sides by 2, y over 2 would be equal to x, subscript 2. And if you square both sides, what you have is y squared over 4 equal to x squared. But I put in the subscript 2 just to indicate that it's a different function from the curve. So x1 is the x term in the curve, and x2 is the x term in the line. All right, so square this, so we get x squared equal y squared over 4. So we end up with y squared over 4 dy. So we're going to integrate with respect to y, meaning we add 1 to the y power and divide by the y power. So the volume is pi, and then the limits are here 4 and 0. Integrate y, we get y squared over 2. Add 1 to the power, divide by new power, integrate this, add 1 to the power, we get 3. Divide by 3, we end up with 3 times 4 in the denominator, so 12. Alright, so we have, of course, we have our pi, and the formulator, 2 brackets. In one bracket, we replace x with, well, replace y with the top value, which is 4. So 4 squared, that's 16. 16 divided by 2, that's 8. Replace y with 4. 4 cubed, that's 64. Divide by 12. In the other bracket, replace y with the bottom limit 0. Is 0 minus 0. So we end up with v equal pi, and then 8 minus 64 over 12, that's 8/3. So the volume is 8 pi over 3 cubic units. Part B, the diagram below, not drawn to scale, shows a graph of y equal 2x cubed minus 6x and y equal to 4x. So we can see one's a line, the 4x, and the other is a curve. What are we asked to do now? Calculate the area between the line and the curve. So we're asked to calculate the area between the line and the curve. Alright? So 2x cubed minus 6x, that's an even function. Sorry, that's an odd function. Notice all the x powers are even, because even 6x, that's x to the power 1. 1 is an odd number. 3 is also odd number. So it's an odd function. So the function here will have symmetry. It will be symmetric about the origin here, which means that whatever this area is, the other area would be the same thing. So all we need to do is find the area for one piece and then multiply it by 2 to get a total area. Alright, also we need to, so the total area would be equal to 2 times the integral, and then we're using 2 functions. We're going to take the difference again. Alright, so area, so again, if that's y1 minus y2. Alright, so the integral is, here is the integral of y. But in this case, we have 2 different functions. So again, y1 minus y2, so we take a difference. So it's actually 2x cubed minus 6x minus 4x. And we're using the limits. We only use one of the limits here. So, we need the point of intersection. We need to know where the line and the curve intersect. Let's find the point of intersection. So we need to equate them to each other. So y equal to this, y equal to this. So we can equate them to each other. So 2x cubed minus 6x equal to 4x. Group everything on one side. So we have 2x cubed minus, bring that over, that's minus 6 minus 4, that's minus 10, equal to 0. We can factor out the 2x, factor out 2x. We'll end up with x squared minus 5 equal to 0. So equate both factors to 0, so we equate 2x to 0, divide by 2, which means x is 0. And we can see here, x is 0 is one of the points of intersection. The other factor, x squared minus 5 equal to 0, which means x squared equal to 5, which means x equal to plus or minus root 5. So I guess this is root 5, this is root 5, and then over here would be the negative root 5. So these are the points of intersection. But we're only interested in the one on the right hand side. Alright, so the total area, so since they are equal, so alright, so it's just 2, that's right, so the total area is equal to 2 times, let me just put shaded area. Since the shaded area is same as the non-shaded area. Now, the shaded area, we're using the x limit. I'll put here x1, x2 for the limits. So this is equal to 2 times the integral. This is 2x cubed minus 10x dx. By the way, dx. We're integrating with respect to x. So dx. And the limits now, of course, is 0 to the point of intersection here, which is root 5. So we find this area, multiply it by 2, we'll get a total area, because this area will be the same as the one area that we shade. Alright, so let's integrate now. So this is 2. Let's integrate now. Integrate 2x to the power of 4. Add 1 to the power. We get 2x to the power of 4. Divide by 4. Add 1 to the power. We get 10x squared. Divide by 2. So this is 2. This is now what? X to the power of 4 over 2. Because 2 into 4, that's half, right? 2 over 4, that's half. 2 into 10, that's 5. So that's 5x squared. And the limits are 0 and root 5. Alright, let's do our substitutions now. So in the top value, we're going to form two brackets. In the first bracket, replace the x value with 5. The second bracket, replace x value with 0. So what we have now, replace x with root 5, not 5, root 5. So what we have is root 5 to the power of 4. Now root 5 to the power of 4 is 5 times 5 is actually 25 over 2 minus 5 times root 5 square. Now root 5 square, so root 5 all square is equal to 5. So root 5, so this is 5 times 5, that's 25. Minus, replace x with 0 minus 0. And of course we can distribute the 2 now. So 2 times 25 over 2. That's 25. 2 times minus 25. That's negative 50. Or we could just work it out and then multiply. It doesn't really matter. In the day I get negative 25. And area is a scalar quantity. So therefore, Therefore, the area, the total area that is equal to, with a positive value, 25 square units. Alright, so that's our solution. Part C. Given that f is an even function, show that f of x between negative a and positive a is equal to 2 times the integral of f of x between 0 and a. So let me do a little sketch here. We're told that f is even, so f is symmetric. If f is even, f is symmetric about the y-axis. So here is x, here is y. Let's say f of x is look like that. F of x would be symmetric about the y-axis. So f of x looks something like that. Let's say you have 0 in the middle here. Let's say you have positive a. And over here, let's say you have negative a. So since it's symmetric, whatever this area is on the left hand side, the area on the right hand side will be the same thing. So the shaded area between 0 and negative a will be the same as a part that's unshaded, that's between 0 and positive a. So let me start the proof here from the left hand side. So the integral from negative a to a my integration give you area would be equal to, would definitely be equal to the integral, the area from negative a to 0 plus the area from 0 to a. And since the function is even, since it's symmetric, this integral would be the same as this integral. So it means that therefore this integral will be the same thing as, we can replace this with 0 to a f of x dx plus, right back 0 to a f of x dx, and then so this is actually 2 times the integral of f of x dx between a, which is what we have on the right hand side. Right, so therefore proven. Part D. Solve differential equation x cubed, rewrite it, x cubed times y prime, and this y prime, this y just means, let me write it as dy by dx. Just to, it doesn't mean y to the power 1. It's really notation for dy by dx equal to 2 minus x to the power of 4, right? So one thing we could do is we'll have to solve, so we want to transpose for y. So we could divide both sides by x cubed. So we're going to divide everything by x cubed. Divide all the terms by x cubed. So this cancel that. So we're left with dy by dx equal to 2 over x cubed, which is same as 2x to the power of minus 3. You bring it up the sign of the power change. Minus x to the power of 4. Divided by x cubed. Law indices, we can just subtract the x powers. So 4 take away 3. That's x to the power 1. This is 1. So, how it works now, remember if you have a y and you want dy by dx, you differentiate. If you have dy by dx and you want y, then you integrate. So we have dy by dx, we want y, so we're going to integrate. Alright, so therefore, y, and let's integrate now. Add 1 to the power, negative 3 plus 2, you get negative 2, right? Negative 3 plus 1, sorry, you get negative 2. divided by the new power. Here the power is 1. Add 1 to the power, you get 2. Divided by the power 2. That's c. And of course, to get the value of c, we can substitute x equal to 1 and y equal to 2. Let's do that. So we're going to substitute x equal to 1, y equal to 2. So x equal to 1, y equal to 2. Replace y with 2. We get 2. Now x to any power, well, not x to any power. X to the power 1. Replace x with 1. Sorry. Well, 1 to any power is 1 to any power is 1. So this becomes 2 times 1 over negative 2. Because this becomes 1 to the power negative 2. So it becomes 2 times 1, right? Minus 1 square, which is 1 over 2, plus c. So this becomes 2 equal, what's it, 1? Negative 1 minus half, that's minus 1.5, plus c. We'll group the half over here, 1.5 over, so it becomes 2 plus 1.5 equal to c. That's 3.5. So c is 3.5. Or you could say 7 over 2. Same thing. So therefore, solution y, remember what y was? This is y. 2 over negative 2. No, 2 over negative 2, that's what? Negative 1. So that's negative, this is negative 1. So it's negative x to the power negative 2, right? So that's negative 1 times x to the power negative 2 minus x squared over 2 plus c, and we just found c to be 3.5, 7 over 2. We just found c to be 7 over 2. That's our solution. Or this x to the power minus 2. One thing you could do is rewrite x to the power minus 2. Put it in the denominator. The sign of the power will change. So that's another way to write your solution. Alright, negative 1 over x squared minus x squared over 2 plus 7 over 2. End of test.